Hi, my name is Justin Griffin, and my group and I are here to talk to you about electric eels. So, one problem that we as a group saw was that there's a very heavy use around the world of lights in rooms that have nobody in them. So, our solution to that is Electric E.E.L.S, which stands for Energy Efficient Lighting System. Now, the way this works is it has a small ping sensor down on the bottom that sends out an ultrasonic signal to detect whether or not a person enters a room. Now, if that happens and somebody does enter a room, it turns on the LEDs located here and then also sends out a radio frequency signal to all the other devices around it, also turning them on. After the person leaves the room, a predetermined time passes and then all the lights turn off, waiting for another signal to turn on.
So for this project, we used 3 Arduinos, 3 XP Pro radio frequency modules, 3 ping sensors, 3 mini breadboards, some wires and LEDs, and some 3D printed parts. However, this all came out to about $275 to create. The way this could be made cheaper would be to use injection molded parts along with a dedicated chip to process the transmitting and receiving signals of the ping sensor and the RF module, which would bring down the cost to about $150. To manufacture our model, we 3D printed the ping sensor mount with LED sockets along with the Arduino mount and the casing for the whole assembly. We then inserted the LEDs into the sockets and soldered all the ground leads together and all the positive leads together to form one large parallel circuit. We then wired up the XB and the ping sensor circuitry and attached the mini breadboard to the Arduino, connecting the necessary leads for the ground pins and the positive pins. We then uploaded the final code to the Arduino board, plugged in the barrel jack, and slid the casing over everything.
The module works like this. Here we have the Arduino Uno, which stores and implements code that controls the 3 main features of this project: the ping ultrasonic sensor, the RF receiver and transmitter, and the LEDs. The ping sensor sends out a pulse of sound and then waits for the echo of that sound to come back after bouncing off a person. Once it does, it uses the time it took for that echo to return to calculate how far away the person was. If that distance is within a certain parameter, in this case 1 meter, the ping sensor sends a signal to the RF unit. The RF unit sends a radio transmission, which has a maximum range of up to 1 mile, to any receiving RF units around it. This transmission tells the LEDs on the receiving module to turn on for a preset time. For demo purposes, this time is 5 seconds, but it could be set to any amount of time. The transmitting module that sends the person then turns on its own LEDs. This entire process takes a fraction of a second. The LEDs are soldered together in a parallel circuit, which means if one LED goes out, it is easy to tell which one it is, and to snip it off and be replaced with another one. This is as opposed to a series circuit, like your Christmas lights, wherein one burnt out LED causes the entire circuit to fail.
So, I'm a chemical engineer.
Also a chemical engineer.
And I'm a cyber engineer.
And the main majors in engineering disciplines used in this project are electrical and cyber engineering.
So having this different view on this definitely helps us with giving us opportunities that we normally encounter. You know, us being chemical engineers dealing with electrical and cyber issues means, you know, it gives the chance to just deal with something we had never dealt with before.
And as a cyber engineer, I would be mostly using this in my career, and it would be an enjoyable career path for me, and I would like to help other people out by doing similar things like this.